Good morning, students. Let's start our next topic, that is equipotential surfaces. As we can see here, the name equipotential is comprised of two words, that is equi and potential. Equi means equal, so equal potential. So the definition that we can have is the surfaces which are having equal potential at every point. Now how can these can be created? This can be created only when the distance from the source charge is equal. For example, if we are having positive source charge and we know that at point R, suppose if I draw a point here at distance R from it. Similarly, at equal distance R from it, I draw the next point, and similarly at equal distance if I draw these points. Now after joining these points, what we will get? We get a surface which is at equal distance from this source charge Q. It means for positive point charge or for negative point charge, right? For positive point charge or negative point charge, we are having equipotential surfaces which is spherical in nature. So basically, if R is same, the distance of the point or distance of the surface from the source charge or source charge density is same, then what we will get is the equipotential surfaces. Similarly, if we are having uniform electric field lines, I have already explained you the uniform electric field lines are those lines which are at equal distance from each other. Now if we want to draw the surface, it is always be at equal distance, it will be a plane surface, right? Now the question comes, why we are always drawing like this? Here we can prove it that equipotential surfaces are always perpendicular to the field lines, or field lines are always perpendicular to the surface. Now to prove this, let us consider we are having equipotential surface, right? We are having an equipotential surfaces. We are representing this as K and L, and A and B are these 2 points on the equipotential surfaces that VA and VB. Suppose if the potential is different, VA is and VB is potential at these 2 points. Now we know that since this is a equipotential surfaces, so VA is equal to VB, right? Now the work done in taking the charge, unit positive charge from A to B is given by VB minus VA into Q. Since VA is equal to BVB, so WAB is equal to 0. It means no work done is done in taking the charge from one point to another over the equipotential surfaces. This can also be understood from the previous topic in which we have said that work is being done in taking the unit positive charge from infinity to that point. Infinity is a zero potential position, and that point, the point which we are considering here, is having some potential. So if there will not be an opposing force, no work will be done. So since these are of equal potential, so no work will be done. Now we have to prove that the field lines are always perpendicular to the surface. Now let us consider a small length element dl over this surface, right? Then small amount of work done in displacing the body, the charge, unit positive charge from through a distance dl is given by E vector dot dl vector. Why E here? We know that dw is equal to f dr, right? Now f is given by q, into E, right? And the dr is here dl. Since q is unit positive charge, so f is equal to E. So that is why we have written here d dot dl. Now this E dot dl can be written as E dl cos of theta, right? Since the work done over the equipotential surface dw is equal to 0, therefore E dl cos theta is equal to 0. Since E cannot be equal to 0, because this is the field lines which are representing the presence of the charge, dl cannot be equal to 0, right? So cos theta is equal to 0, or we know that cos theta is 0 when theta is equal to 90 degree. It means E is perpendicular to dl, that is E is perpendicular to the surface. E is perpendicular to the surface. So this is the direction E and this is dl. So it means that electric field lines will always do perpendicular to the surface whatever the source charges we are having. Coming back to the point, when we are having point charge, and if I draw equipotential surface, it is again perpendicular to the surface at every point, right? And if I am talking about the uniform field lines, and if we join points at equal distances, then this surface, which is a plane surface, is representing the equipotential surface. It is also perpendicular to the field lines. So this shows that electric field lines are always perpendicular to the surface.